Okay, hello everyone. I am Fatma and welcome to our 10th Creative Chaos Learning Series. This time we have Muhammad Saad Javed with us. So let's just start and then Saad can give an introduction. Yeah, over to you, Saad.
Thank you. Thank you, Fatma. Welcome, everyone. My name is Muhammad Saad. I'm 8+ years of experience software developer. I have designing and development experience, enterprise application from scratch. I have worked on multiple domains in e-commerce industries, publication industries, and real estate. So in today's session, let me just share my screen. We will discuss about some key features of software development related to its design and architecture. Let me know when you can see my screen.
Yes, we can.
Thank you. So, we will be discussing clean software design and architecture, and in this discussion, we will try to cover some major components related to the clean architecture development, where we will also discuss about CQRA design pattern, how we can separate out commands and queries, and then we will also see the pub sub model, which is called publisher and subscriber model. So before getting things in detail, I would like to discuss about the significance of the software design and architecture. As you know, in our daily life, we have very close interaction with smart devices. It can be a laptop, even a fridge, which have digital control, AC, which you control with your remote. It's also a digital device, and even a car which has electronic brakes or some electronic modules. So they all built on different softwares are integrated in them. So just to give an example of a car, so for example, if you push a brake, so the brake will just notify your computer, the controller of the engine, that the car needs to be stop at this particular time. There will be set of instructions, set of commands will be executed by that software, and then pressure brakes will be applied, and your car will be stopped. So what if the code written there does not work properly, or it not working intended in it should be, or some edge case happen and it breaks because if case is not handled there. So a nightmare could had happened, and we have a history of such nightmare which are already being happen. For just take an example from car industry, we have incidents where a Toyota company recall many cars and they fix a software problem there, where actually car was starting to accelerate by itself, and it was a software issue, and it led to many deaths. And similarly, in Los Angeles airport, a traffic control software failure happened, where somehow the system was not working properly, and the flights which were directed by the air traffic controller to different directions, they were just about to collide with each other, and it was all software failure. And there are many such examples exist, and these failures happens because of poor design and poor architecture. This is one of key fundamental problem if we see different case studies. To have a good design and architecture, we will discuss all these things. What is a good design architecture and how we can improve our architecture, and which solution suits which particular problem. So we will be discussing when we should apply one architecture and when we should not apply that architecture. So let's move to our content. Here we will be first discussing a clean architecture. Then we will move to a CQRS pattern, which is called command queue responsibility segregation. Next, we will discuss mediator R, which is a library, and it is very helpful when we try to implement CQRS in .NET. Next, we will discuss about publisher subscriber model, how we can have different microservices interacting with them without any dependency with the pub-sub model. So we will be discussing that, and then we will see everything which we discussed today in a code demo, and we will see how the things work in a code in a .NET application. Lastly, we will have your questions and I try to respond to them. So, clean architecture. Let's discuss first some key points. What good architecture should be like. What are key points that need to be answered by a good architecture? So, I try to answer these questions with following points. This is my experience, and my research says that a good architecture first minimize the human effort to build and maintain that system. See? And next is we should be changing our system only because of business requirement rather than just because of some technology change or upgrade or things like that. So we should build system because of system requirements, not because of the technology preferences or things like that. So I feel, in my experience, usually it's a practice that we do not much emphasize on the business requirement. Rather, our focus is what going hot in the market as a technology perspective, which we want to learn as a developer, as an architect, we want to implement. We just put that technology irrespective of saying that this specific business case needs this technology or not. So that's, I think, very important when you are having a good architecture for a system. Next is, of course, your architecture should communicate the purpose of the code, and you should be able to get what actually this code is for, not in terms of technology, but in terms of business rules. And a good architecture differs major decision. What I mean by this is that, for example, you are designing an web API and you are very early phases of it, and you know some time later you have to include an PubSub model, but that is not the requirement at the time. And at this beginning of the project, you should not be worrying about which specific technology you will be using when you will implement PubSub model. Either it will be event grid by Azure, it will be a RabbitMQ, it will be a Kafka, whatsoever. So that decision can be tougher. So when the requirements come to that stage and you can make a more knowledgeable decision based on the application you have previously built and work on that and experience of this usage, then you can take that decision. At the start, if you need to take this decision, it's not a good approach because you have no idea how your application is going to behave in the real world, and you are very beginning phase. Next is a very important point for a developer perspective. Being flexible is wrong in wrong places is bad example of software architecture. So sometimes architecture allow us to make any change, which led to many human errors, and of course, because of it, our overall software quality suffers. So I would like to start the discussion of clean architecture with the saying of Uncle Bob, which is being called as parent of father of clean architecture, that we should think about application as group of use cases that describe the intent of the application and a group of plugins that gives those use cases access to outer world. So we will see in the coming slides that what it means by yeah. A clean architecture is a design pattern. It is introduced by us, Robert C. Martin, which is also known as Uncle Bob. It's architectural styles suitable for all platform, all languages and domain. But in current session, we will be seeing it implemented in .NET, specifically .NET Web APIs. And it states that the clear separation of concern by dividing the application into concentric layers, with each layer having its responsibility and dependencies. We will be seeing each layer of the clean architecture in very details in upcoming slides. And another important mindset of this clean architecture, which is it emphasized on, is that abstraction should be mindset instead of concrete rules. So our application should build on abstraction rather than on concreteness. And how can we achieve it? We will see it in our demo. So next, benefits of clean architecture, if we see, is that it makes us independent of databases. Your data stores, you want to store your data in whatever database, either is SQL, NoSQL, Mongo's, file storage. So it separates out totally. You can incorporate any data store or any storage mechanism can be used to save your data, and it allow you to get work independently without worrying of the frameworks. You can incorporate the framework with decisions, but it is not intended from being decided from the very start. Does somebody raise the hand?
No, someone joined, so उसकी आवाज थी.
Okay. So, next steps are very simple. They are easy to adopt, easy to testable. It make high module isolation and always ready to deploy. Here we have two views to see our clean architecture. One view is called onion view, another one is called cone view. They are basically different representation of same architecture, clean architecture. First, you see in the yellow box, in the inner box, we have an entity layer, and which is the core of our application. I would like to use the word domain for it. These are your business rules, your core entities, and your entity aggregates, things like that. And then you have use cases, and I will explain what use cases is when we get to that layer. And then we have controller, presentation layer, gateways, and lastly we have our infrastructure layer where we have web UIs or external API client databases and devices, things like that. So a general rule is explained in a architectural cone diagram, which says the abstraction level increases as we go inside uh, these circles. So entities, the core of the application has most of the abstraction. Rather, the infrastructure layer has least abstraction and more of the concrete implementations. So these rules need to be understood before we move further. So what goes in a domain layer? Domain layer encapsulate business rules, which are uh, general to your whole domain, and it includes your base entities and domain specific logic. It should be technology agnostic and contain no dependency on external frameworks or library. So a domain can be something which is independent of dependencies and frameworks. It will be dependent by next upcoming layer, but as itself, domain layer should be independent of dependencies. Next is our application layer. In an application layer, we have use cases. Use cases are basically we can state that these use cases orchestrate the flow of data to and from the entities. By entities, I mean our domain layer, and direct those entities to use their critical business logic, the domain layer business logic, to achieve the goals of the use case. So use case are basically business logic which we have in our system to solve business problems. So that business logic states in the application layer. Next, we have presentation layer. A presentation layer can be, in case of web API, our API controller endpoints through which our user can interact with our systems. Next is our infrastructure layer. Infrastructure layer where our databases, external services, and frameworks live. So all the external services, file systems, web APIs, which we are dependent, our application dependent upon, or something. If we take an example of PubSub model, we need a message broker that also lies in infrastructure layer. So these are different layers of clean architecture, and we've seen them in detail. Let's compare this clean architecture with normally used n-layer architecture. So what previously we have a plain data layer where we have data store, which can be any type of databases. Then we have all the logics and all the POCO classes, everything in a business layer. And then we have one presentation layer. We changed this to onion view, onion model, where we have a domain centric and independent of any dependencies. Then we have our application layer, which holds the use cases. And then we have our presentation layer, where we have the endpoint to interact with our system, our application, our use cases. And then we have our infrastructure, which are our dependencies, external sources, which interact with our system. Last two key rules of we have for clean architecture is dependency rule first. It says that all dependencies should be point inward. So it will be like A UI layer will be depending upon our application layer, and an application layer will be depending upon a domain layer. And similarly, infrastructure layer will be depending on application layer, and application layer is already depending on our domain layer. And data flows, I have mentioned here. And from UI, you want to present a layer, then use cases, then from use cases, data is being fetched for repository, and the vice versa for returning the data. So in a holistic way, view where we want a real world application, how it will look like. It will look like something like this. We have a domain box on the left bottom, which includes the domain entities, domain events, value objects, enums, and constant. And then we have application layer, which have the different validators, behaviors, mappers, request model, DTOs, interfaces, contracts, business services, business logic will be held between these business services, and then application exceptions and things like that. In the user interface, we have controller view, view models, and things like that. And in our infrastructure layer, we have our data persistence, where we have iterative framework, we have generic repositories, in-memory cache, distributed cache, repositories implemented, and message queue for PubSub model, file storage, and any external dependencies will go in our infrastructure layer. So this conclude our clean architecture, and we see how these layers are being separated and how their dependencies goes and what goes in which layer. We will further see this information when we go to the demo phase. So do we have any questions related to this clean architecture? Okay, then let me ask you something. For example, if you need to add a, something which is required both in infrastructure layer and application layer, where will you add that? Seeing this picture, can somebody answer to it?
Application layer.
Application layer, but it is also needed in infrastructure layer. So you can you application layer already have dependency of the infrastructure layer. You cannot have circular dependencies. So any thoughts about this?
So you can use dependency injection to inject the dependencies in the infrastructure layer.
That's very right. You can use the dependency injection, but where actually you keep that particular thing? For example, you have a date service, which is being used in both of the services, like application layer and also in your infrastructure layer. You need a specific format of the date, and that date
Can you
service.
share screen again? Can you
Yeah, can
share
you?
screen again?
Yeah,
Sure,
your screen.
sure. My question was, we have something which is required in two layers. One is application layer and other one is infrastructure layer. Where we put that thing, and I am giving an example of a date service, which specify a particular format for a date, which is being used by both of the layers. Where we put this date service, do we put in application layer or infrastructure layer? How we can make it possible that both layers can use that date service? Okay, I think I haven't explained it.
Utilities.
Yes, this is a very good point. Utility. We have a concept in clean architecture which is called cross-cutting corners. In cross-cutting corner, we have the things which is being used by layers like both layers like application and infrastructure layer. But we have to be very wise to put anything in the cross-cutting corners, because otherwise we will be putting everything in our cross-cutting corners. So that's a very important point when you implement this architecture. Thank you, Iqbal. I think we can move further. You can see my screen, right?
Yes.
Yes. Next is command and query responsibility segregation pattern. Command and query responsibility segregation pattern says it separates out the part of command part of system from the query part of the system. What I meant by command part of the system, the create, update, and delete requests are called as command in this pattern. And the queries are anything which basically reads the data from a databases. Why we need to use it? Yes, if we have a collaborative domain where there are numerous users can view the same data concurrently, then we need to have a separate scaling for a
Sir,
query part of the system. Yeah. One other important part of the CQRS pattern is when you have heavy traffic systems, where you have many read being happening concurrently on your system, and you need to scale your query part of the system separately. So that's a very important use case where you need to apply this pattern. So, good example of this, you have a product information system where you very frequently reading this product information, but very rarely adding the new product details. Just take an example of Amazon.
Saad, please unmute yourself. I think someone muted you. Saad,
Sorry, a product in a system can be added very rarely, but its read operation will be required very frequently because hundred of the users will be reading those products. So to scale our application to this extent, sorry, I think my presence was not there. Yeah. To scale a system to this extent, we need to separate out our read part of the application. And for that, we need CQRS pattern. Then we also have some cons related to it, which is like if we want to avoid complexity in the system, we should not be doing it because adding a CQRS will complicate our system. If we want to avoid eventual consistency, where we do not want our read and write databases are separate and they get stale somehow, and we have inconsistency in data, if we want to avoid that, such like in a fintech application, we should not be implementing CQRS. And similarly, if we want to avoid delay in synchronization, because this in this case, our databases will be like on a high availability where we have one master and multiple slaves and they are being replicated, and on master we will be writing and from slave we will be reading, and once the change comes to the master it will be synced to the slaves, but it can be delayed. So in that scenarios where we need very synchronized data, we should not be implementing CQRS. Next, let's discuss about Mediator R. Mediator R is a library which is being used in C# for implementing CQRS. It has very good application. It decouples your application. It has capability to add behaviors in your pipeline, and it has very good features where it can automatically discover the handlers, which can be of your request handler and it can be of your notification handlers. We will see this Mediator R working in our demo. Okay, let's move further. We have publisher subscriber model. Publisher subscriber model by name, I think it's very easy to understand, is an architectural pattern which distribute the asynchronous communication between different component of the service. The messages exchanged between the publisher, the one who is sending the message, and the subscriber who is receiving the message, and subscriber can be more than the one, is where we need publisher subscriber model. It loose couples the dependency between the components like the system which are interacting with publisher subscriber model, and it has high scalability, and it's asynchronous and event-driven application that ideal for real-time and low latency apps. And we also have a case where we should not, we have a case when we should use this PubSub model, like sending notification, distributing caching, distributing logging, working with multiple data sources, broadcasting updates, one to many, one to one, something like this, and building responsive, low latency and high available user experience. And there are also some cons to it, wherefore we should not be using this model in case where it's overkill for a simpler system, where it is not suitable for media streaming. It is inappropriate for periodic and background tasks. And if we do not want to have a event-driven system, we should not be using PubSub model. And if we want to have a synchronous communication in a system, we should not be implementing a PubSub model. So do we have any questions? Otherwise, I would like to move to our demo. Okay.
Do you have a question?
Gigi.
You mentioned a scenario where you recommend CQRS, right? Where you have a lot of data and um, like data warehouse project, right? For instance,
Hmm.
or you gave an example of Amazon, right?
Hmm.
Can you give an example of PubSub project or real-time, real-world example?
Of course, of course. My PubSub example is a very common use cases. For example, I have a user microservice, and I also have order microservice. So for some XY reason, my user in a user microservice is now deactive or inactive, and I want to stop its order being processed by another microservice in order processing service somehow. To stop that, we can have a PubSub model where the user microservice will publish a message that this user is inactive. So whatever subscriber, in our case, we are taking example of auto processor, will halt its operation related to that user. And it can be some other subscribers like a email marketing service will just also include this information and stop sending email to that user or something like that. So we have one publisher which sends the message to a message broker on a queue, and we have multiple subscribers which took this message and take action according to the message. I think
Thank you.
I have answered your question. Okay, let's move towards the demo.
I do have one question.
Yeah, sure.
So using CQRS pattern, it is required to return the data while sending the command or not?
It's totally up to your business requirement. It's not requirement of something dictated by the CQRS. It's about your use case, and we will see such use cases.
On top of that, what's the normal practices? Should we return data on post put, or should we say that the data should be only accessed by a GET?
Sorry, I can't get your question. Can you repeat?
So, as Abdulrahman mentioned that in the post and the put request, right?
Mm-hmm.
Normally we do return the data, the added data or the updated data to the caller, right?
Mm-hmm.
There is another mechanism where we can just return that status is updated or 201 that record has been created, right? And we'll educate the end user that you just need to call the get APIs in order to have the data, right? And
So
you mentioned that CQRS, it's up to you.
yeah,
What's the normal best practice?
so usually we want to avoid multiple calls to our APIs. So if a data is updated, so a normal scenario could be like we shared the updated data back to in our response, so that our front end should not be calling our APIs again and again to fetch the same information. So that's the practice. But of course, on different scenarios and different working conditions, we can change it. And considering different security parameters, things like that, we can change it. But this is usual practices. So I
Absolutely.
think,
But
I
one last
think,
thing, that the query part is in
mhm,
CQRS, you explicitly divide the command and the queries, right?
I
Now
got your
your
point. Yeah.
queries, yeah, your queries are more optimized that EF has no tracking on them, right? For instance, right? So
Mhm.
your query are meant to be optimized in a fashion that they will respond faster as compared to your commands. So
That's not really the case. As I mentioned, usually we use the CQRS pattern where we have high scale databases, high availability databases, where we have replicator databases. We establish one master database and multiple slaves, and we usually write on our masters, and they automatically sync this information to the slaves, the similar replicas of same database, and this can take a bit of milliseconds, a bit of time. But for the user who just send us information to give the updated response, I think that milliseconds of the wait in that if they send the request to a slave and it's not synchronized yet, it will be I think, not a good experience for the user that data has been updated, but he is retrieving the old data. So to avoid that, we return the updated data in update code. But of course, it can vary from case to case. I think I have answered your question, but I think we should jump into the demo. We can have another session of questions at the end of the demo. Okay, in this application, I made 4 layers. One is a presentation layer. It's just related to our plain architecture guidelines where we have an API in a presentation layer, we have an application layer, we have a domain layer, and we have an infrastructure layer. So I will start by showing our dependency rules, how the dependencies in this project work. So if we see in our domain layer, we go to dependencies and we see I have no dependency on any of the project related to the system. I do not have dependency on application layer or infrastructure or any of them. And if I go to application layer and I see the project dependency I have on domain. So a domain was center, a core, and an application was dependent on it. And similarly, if I go to infrastructure layer and it's respectively dependent on application layer and then application propagately depending on domain layer. So it will hold the domain layer things and also the application layer of things. And API, we see the project structure is dependent on application layer and infrastructure layer, and they hold dependency to domain layers respectively. Yes, first I would like to show you what I put in a domain layer. Before getting into a domain, I want to explain what we have going to see in this demo. I just create a block class. This demo is just a web API where we will be adding blocks in a database. I am using the SQLite database here. And we will be seeing CQRF working. We will be seeing PubSub model working. So everything is part of this demo. In a block database, I have just entity block, which has an ID, name, description, and author. And in my application layer, I have a component, a feature, which I would like to call block, and it has certain commands, it has certain queries, and it has certain event handlers. In commands, if I go, I have some commands related to create block, delete block, update block, and in query, I have some queries related to get block by ID and get all blocks, things like that. So we will see first an operation where I would like to show you complete. I will debug with you complete request where we'll be handling a create block command, and we will see how it works in a demo. Before going to that, I would like to show I added some comments. I added a behavior, which is I mentioned earlier when I was explaining mediator R, that a mediator R provides us option to add a pipeline behavior, which works on our request pipeline, request and response, and I am adding validations in these behaviors. And these validations are separate for every command. And if I show you for create block, I have written this validator. And in this validator, I just verifying the name is required or limiting its length, similarly for other properties. And I have separate validators for other commands. It can be added separately, but I have written it, for example, for create block command. And to understand a command, first I would like to show you is that a command is a I request, it's implement I request of the mediator R, which takes an entity that on which entity we are creating this command. I have a view model object, which is
Saad,
called, yeah.
sorry for cutting you off. Someone is requested to zoom in a little because we can't really see it that clearly. Yeah,
Is it better now?
thank you.
Sorry, apologies. And a block view model is just a view model based on our block entity, and it's the same properties. And I just mentioned from a mapper that it will be mapped from block entity. So I just do it in a fancy way, a mapping operation where I create a generic interface, and I'm using the mapping between to block block view model to block without specifying specifically any mapping. So it's another way to do the mapping. Let's go back to a command. A command is just a set of parameters here, and we have a handler which will be handling this command, and how a handler will know for which command it will be handling. We have specified it here. We specified here that this is a request handler, create block command handler. This implements I request handler for mediator R, and it's working for the create block command, and it will be returning a block view model. So when I send a request to to create a block from my API, what will happen? Let me show you my controller. In my controller, I just have a mediator R and I call it send on a command. I'm taking a command as input and I'm sending, just calling a send method. And as in my presentation, I mentioned that this is automatic handler discovery done by the mediator R. Mediator R sees that I have received this command. Do we have any register or any handler for it? And we have already specified its handler for this command here. So let's run our application and see how it goes through. Just before jumping into running this application, I would like to show you how my databases is working. So for the databases, I have created, where is my domain layer? Yeah, in my domain layer, I created iBlock repository, an interface for my repository entity, but it does not implement in my domain layer. Rather, it's being implemented in my infrastructure layer, where I specify how this repository will be executed on my database. So I have my DB context here, and I have implementation of this repository in my infrastructure layer. So I show you in a cone representation of clean architecture that our abstraction should be in domain layer and our concrete implementation should be beyond the upper layers. So in case of repository, having my repository's complete concrete implementation in infrastructure layer, we will have a big point also here and its interface in a block repository. I explained two things to you. First one is clean architecture, another one is mediator R with CQRS. But I still hold the PubSub model, which I will explain once we see how application works when we send it a create command. So let's quickly run it. Okay. So I have added Swagger, Swashbuckles to it. And I have different controllers. Let's just go to blog and I want to create it and I just name it Swagger. I'm writing a blog on Swagger and it is just random, some dummy text here, and I just put my name in the author and I execute the command. So first we landed on our controller and our controller hit a create action. Let's move from here, where we'll land next. So any guess where we will land next? I give you a walkthrough of the application. Anybody like to guess where we will land next? Handler, good. Okay, let's see where we land next. So before landing the handler, we landed on a validator. And how it happens? Yes, you are right. Logically, we should be landing on handler. But I show you that I already put here a behavior which is controlling my validations. It is in the request pipeline. When a request comes in, my pipeline behavior will first calls and it will make sure that it will verify all these things. And if some error is here, it will return the exception. Otherwise, it will move to next. So my behavior calls in and it calls my validator. And afterwards, I land on my handler. So this is how pipeline behaviors works. And once pipeline behaviors completed its work, we land on handler and we receive the request here. So from here, we will go further where this is part of our application layer. We are in our application handler and we receive the request. We change it to our entity. We map the entity and we call our repository. And I'm guessing you will also be guessing that this will be landing in our infrastructure layers repository where we will be actually saving this in our database and returning the block. Yes. So up till now, what has happened? We have an entity. We receive its handler's call. We receive its command in a handler. First, we did its validations. Then we handle that command in a handler, and we save that request, the block in a database. Now, I would like to show you how PubSub is working. So for PubSub model, I have implemented events to handle this. So on my entity, if you notice, I have added an interface which is called I have domain event. So I would like to avoid the errors by which I will be sending the event for the entities which shouldn't be pushed to my message broker. I will cater this by handling an empty. I has event interface. It has nothing in it. It's just specifying that this entity will be sending some kind of event. Then I have a strict class which is of type domain event, and I have some properties which will be generic to every event, like date occurred and event type and entity on which this event happens. Next, I have upsert event to handle both of the insert and update scenario where I inherited from domain, and I also mentioned that this generic class which will be going to be for which event is going to be happen has implemented I has domain event, and I'm just populating the default values there, entity name and event type, because I already have this information here. So in my domain layer, I created my event, and then I go to my application layer where I have my event handlers. Okay, and here I have blog upsert event. So in before we see a blog upsert event, I would like to show you that we have also configured a RabbitMQ infrastructure layer, which is implementing RabbitMQ service, which is implementing our event publisher, and our event publisher is in our domain layer, which will specify that this event will be published by calling this method. So we have RabbitMQ message broker, which is being called through this interface. Let's get to our event handler now, where we have upsert event, and I have mentioned that this push notification will be handled by it. Okay. And here is one important thing is we have notification handlers, but we also need to specify a notification. In my notification class, I said that you will be receiving a generic T-domain entity, where T-domain entity will be a domain event type. As you remember, we have a generic abstract domain event class, which is implemented by our event concrete entity upsert event. So in my notification class, I'm just specifying that this notification has been handled, has been happened, and then my notification handler will receiving that notification and calling my event publisher to push this event on a respective message broker. So application layer does not know that this message is going to be placed on RabbitMQ. It will only be happen when uh, in my API, I configured this app settings for RabbitMQ, and in my program class, when I inject my application, my infrastructure layer, in my infrastructure layer, I specify the setting for whatever message broker I'm going to have for this notification handling, and then I specify it by implementing a event publisher service. So let's go to our event. I know it's a bit complicated, but once you see it running, it will be joining the dots. Let's just run our code further. I have my breakpoint in my blob upsert event handler. And previously we were in a command and we were executing our handler, and we just stopped by creating a publishing our domain event, which was of type upsert on entity blog. So let's just, I'm pressing F continue. I just press continue and my upsert event is being created. Okay, and now you see we landed on our event handler automatically because of mediator R. It identifies that a domain event has happened of event type upsert and on entity block, and I already registered a notification handler for that, and it automatically reached to this point. From this point, I will just press the continue. My message will be sent to the message broker. Okay, so my message is sent to the message broker. We will verify that, and I get the response that this information has been saved, and this was the ID and things like that. Let's go to a RabbitMQ and see what's happened here. So on a RabbitMQ, we just received one message, and this message is now available for us subscriber to read, and then they do the respective part. So I completed in my demo the first part of it, where we push the message to the RabbitMQ, and from the RabbitMQ, this message can be taken by any subscriber, and they can take the respective action on it. Just quickly go through how a message look on RabbitMQ. So I just explore my message from the RabbitMQ. So it says we have a new message where we created ID2 and the blog name was Swagger, description was this, author was me, and we have this event on this particular date and time. This event type is absurd, and on which entity it's happened is blog. So my consumer, the subscriber of this message will be making sure that this is absurd event happen on blog entity, and they can translate this JSON on blog entity, and they can do their respective operation. So this is how we publish our message on our RabbitMQ. So let's just go through quickly another operation, another command, which is of delete type. So we just created a blog which is of ID 22, and I just press continue to delete it. So I first landed on my controller. It's this API controller. You can see from here, if I send it further, so I landed on my delete command handler. You can see that, and in delete command handler, similarly, it will call the repository first to get the information, then delete that object, and then the deleted object will be pushed to my RabbitMQ so that we can notify our subscribers that this entity has been deleted. So yeah, so we got the response 204 that this object has been deleted, and we can also see our RabbitMQ that we have received another message. Let's pop that out also. Okay, we have two messages. One is previous one was of absurd type. Now we have another one which is of type entity has been deleted, and we have mentioned the entity and respective data of the entity is also there. So the subscriber can get the information from here and update their system accordingly. So this was our demo. Do we have any questions related to it? I would like to share with you. There are some other good things I included this time. I would like to share it on GitHub, which can be shared with you afterwards. I inject a dependency layer by layer, which is a very good feature which can simplify a program class. So if you see my program class, I have just mentioned that I'm adding a layer dependency. My application layer is being added, then my infrastructure layer is being added. And my application layer, I just created a configure services class where I'm adding all the dependencies which are required by the application layer. And similarly, in my infrastructure layer class, I have also created a configure services class which includes all the dependencies which is required by infrastructure class. And then I inject all of them in my program class, and my program class will look very simple. And this is called layer injection in the program. And one other thing which I will like to show you is mapping. I think I have already explained to you. I have IMAP interface, and I create a map for it, so I do not need to create mapping for every object manually. It's take a generic and create mapping between its concrete type. So for that, I also need to register it in this particular way. So this all code will be shared to you, so you don't have to worry about it. So just let's quickly see one query working before we end the demo. Okay, get blocks, and I just put a breakpoint in my block handler. I think my code is running. Yeah. So let's get blocks, and I just get all of them. Oh, I forgot to add the breakpoint on my API controller. Sorry, on my block controller. Yeah, you can see my mediator is the one which is command is being executed. So in my handler, I just call my repository, and in my repository, I just read the data from database and I return it. And this is how my query part will be working. And I get the response in my Swagger, things like that. So we see a cycle in which we create a block, then we delete it, and then we read this information. First, we work with a create command, then we work with delete command, then we work with a query. And we also see all the information related to the clean architecture. Then we see how CQRS work, how we separated out commands and queries. And then we see also event publisher, how I handle it in this demo. The approach to manage these things can vary, but this is how, the best of my knowledge, things should be happening in a real world example. And you see how much flexible a clean architecture is. We should not be worrying about which database we are using. Our whole application layer is work on interfaces, which is being coming from domain layer or application layer. Then our infrastructure layer will be implementing those abstractions, those interfaces, and then we will having our dependencies just on infrastructure layer. So for example, but what I have to do if I want to change from message broker, which is currently RabbitMQ, to Kafka, I just have to implement this interface. And in my infrastructure layer, I will just create this Kafka service where I will implement this event publisher service and give it method implementation. And my whole application will be working with Kafka. I do not have to change anything in my domain layer or my application layer. So this is a very good feature coming with this clean architecture, and it make it very easy. And same thing can work with like I use uh, SQLite here. If I want to change it to Mongoose or something simple MS SQL, that can be happen. I just have to change my DB context here and relatively because with respect to the database I'm using. So I do not have to change anything at my domain layer or my application layer. So my all the use case in my application layer will be intact of the framework of the dependencies of the infrastructure dependencies which I have. So my business logic will be not affected by the technology or by the framework which I am using in my infrastructure layer. So this is a very good feature of having clean architecture. All right, let's jump back to our slides. Okay, thank you. If we have any question, I think we have.
There is a business logic should go into handler question mark.
Yes, business logics can go to the handler. Yes, of course. But it depends if a business logic is something your whole. Uh, but I think one point here is to understand we should be understanding what is business logic, what is application logic, what is the use case logic. A business logic is something which is true for your whole of the application. If something's like that is part of your business logic, that should be going to your domain, which is true for all entities of your system. If something like that, if something is particularly only for a use case only for a particular scenario, then that will be handled by handlers. And that handlers then further incorporate modules or components, of course, if we have complicated logics. Yeah.
Do we have any more questions? Okay, so okay, I think my Can you guys hear me?
Yeah.
Yeah. Okay. Denise has a question. Yeah.
No, I accidentally raised my hand.
Okay. Anyways, thank you everyone for joining. Thank you for being a great audience, and we apologize for the inconvenience in between. We will be sharing the recording on our YouTube channel. Thank you, Saad. You did a great job. So we will be sharing the recording via email as well to everyone who registered, and we hope to see you for our future sessions as well. Thank you.
Thank you, everyone. Bye bye. Allah Hafiz.
Thank you. Allah
Thank
Thank
you.
Hafiz.
Thank
you.
you very much. Allah Hafiz.
Allah
Thank you,
Hafiz.
Saad. Allah Hafiz.
Thank you, Allah Hafiz.